In this video, we will cover section 2.3 on functions. It is very important that in this class you watch the videos or read the slides posted on Moodle or read the corresponding section of the textbook in order to review the content that will occur in the upcoming class. So for the first class, we will cover both sections 2.3 and 2.4. So it's important that you review the content before the class so that you are prepared and so that we can spend more time solving exercises from the textbook instead of reviewing the content needed. So we want to apply these concepts to solve problems, and so you need to be prepared ahead of time. This way we will spend less time reviewing the concepts and more time applying the concepts through solving exercises together as a large group, and then you will have an opportunity to solve problems either individually or in small groups in order to prepare for the quizzes, assignments, tests, and exams with the help of me, your instructor, during class time. Okay, so let's review what we will cover within this video. So by the end of this video, you should be able to recall the definition of a function and give various examples. You should also be able to draw graphs of various functions, including the floor and ceiling functions, and define the floor and ceiling functions. This additional learning outcome, use the floor and ceiling functions to count the number of integers in an interval, is an application of the concepts you will learn in this video. So this outcome will not be covered within the video, but instead we will apply this in the class, and we will solve an exercise together, and then you have an opportunity to solve more exercises on your own with the help of your peers and myself. Okay, so let's begin by reviewing the definition of a function. So let's let a and b be non-empty sets. Then we define a function f from a to b and denote it in the following way: f colon a arrow b. So this function is defined as an assignment of each element of the domain A to exactly one element of the codomain B. So we write f of A is equal to B if B is a unique element of the set B, the codomain B, assigned by the function f to the element A of A. Okay, so let's look at a particular example to make this definition a little bit more clear. So let's consider our function, we'll call it f, from our set A, which consists of these four students, and this set A, these students, is called the domain of the function, and we'll let the set B be their grades in, let's say, Math 2320. So the set B is what we call the codomain. So a function is defined from the set A, domain, to the set B, the codomain. And so in our particular example, our domain is going to be a set of students, in particular these four students, and our codomain is going to be letter grades from A, B, C, D, and F. So the function is an assignment of each student to a letter grade. So every student is assigned a letter grade in the course, and this assignment is denoted by this arrow diagram. So a function can be defined in a number of ways, and we'll see a number of ways throughout this video in which we can define it. But the first simple way, when we have particularly finite sets of students and sets of grades which are finite, it is easy to define this particular function with an arrow diagram. So what makes this particular assignment a function? So we note that a function is an assignment with a particular property. Each element of the domain A is assigned to exactly one element of B. So that means that this is a function because every element in the domain, the set of students, so every student here in this set, has exactly one arrow coming out of it. So it is a function because each element in the domain has an arrow coming out of it, and moreover has exactly one arrow coming out of it. So it is assigned exactly one element of B. So each element of A is assigned exactly one element of B.